In the course notes, when we were talking about symmetry and operators and stuff like that, at one point in time, we've derived the following equation. We said, okay, if you have a system which has a certain symmetry, that means that the operator which describes that system, in our case, that was the theta Maxwell operator, that operator is also equal to the following expression, OI minus 1 theta OI, where OI was the operator expressing the symmetry. And in our case, that was inversion symmetry. And we've also said, okay, we can illustrate that expression graphically. We can say either, for the left-hand side, we directly operate upon a certain vector function with our theta operator. That's the left-hand side. Or for the right-hand side, we can do the following. We can either first then operate with OI. So remember, these operators, they evaluate from the right to the left. So first we have our operator OI, which will actually bring us from a coordinate system of R to a coordinate system involving minus R. Then our second operator is just, again, our operator describing the system. So that's capital theta here. And then finally, we have the inverse operator. So this is OI minus 1. And this operator brings us back to our good old-fashioned R coordinate system, such that we're able to compare apples to apples and not some other type of fruit. So either you go directly like this with the black arrow, or you take the red path, which involves these 3 steps here. But if you have symmetry, that should be equivalent. Now you can make a trivial modification to that formula. You can just multiply everything by OI. And then we have OI theta equal to theta OI, which basically means that the commutator between these two operators is 0. And the question is, can you now also have a graphical representation of this particular equation over here? That's fairly trivial, so pause the video for 2 microseconds and then we'll give the answer. Okay, that was a long 2 microseconds, but let's write down what this equation actually represents. So first of all, let's have a look at the left-hand path here. On the left-hand side, we first operate with our operator theta. So that's this arrow over here. And what we do next is we operate with our symmetry operator. And that brings us over here, OI. And again, this brings us from the R coordinate system to the minus R coordinate system. Now for the right-hand side, that's the second path. Let's do that in some nice communist red here. So the first thing we do is the inversion operator. That's this guy over here. And then we apply our theta operator. So that's very trivial, different representation of that formula over here. And if you have symmetry, these two things are equivalent, or these two operators commute, so their order doesn't really play a role.